In this lecture, we are going to talk about big data, analytics, and RPA. In the past, we rely on traditional data that comes from ERP systems or paper-formed documents. But nowadays, we have data coming from scanners, which can tell what you buy and can predict your behaviors. And we also have data collected from websites, such as your click path, the websites that you visited. And with the GPS, we also have data about mobility. For example, where are you? Where have you been? And nowadays, we also can collect data from surveillance videos, for example, security videos. And we have videos from social media, from news media. And the social media is creating a tremendous amount of data available. And the social media is one of the main sources that generates tremendous amount of data. So all these data combined creates the so-called big data. Big data is generally defined by using 3 V's: volume, variety, and velocity. Volume means that the size of the dataset is very big. And the variety means that there are so many kinds of data, including textual data, numeric data, video data, image data, and so on. Velocity means that this data is generated in a very short time. So just imagine how many tweets can be generated in each second. Now, how can we define how big is big data? Here, the definition for big is not fixed because as technology progresses, our ability to process big data also improves. So the big is a relative concept, but in general, we refer to big as the size that is too large or complex to be dealt with by our current technology. Now let's look at the following examples and classify each example as big data or not. First, Google daily search queries. I think this is big data because each second can generate a great amount of Google queries. Second, yearly revenue data of all US public firms. This is not big data because there are only around 3,000 US public firms as of today, so the yearly revenue data is really not considered as big data. Third, tweets generated in one day. This is similar to Google daily search queries, so this is considered as big data. Next, weather patterns around the globe. This is considered as big data. Last one, demographic information of all students in Rutgers University. This dataset can still be dealt with by our common analytics tool, so this is not considered as big data. Now that we know what big data is, let's talk about data analytics. Analytics tools are used to uncover hidden patterns, unknown correlations, trends inside the data. And here the data is not limited to big data. We can apply analytics to all kinds of data sets. However, the term data analytics becomes extremely popular together with the concept big data. There are 3 types of data analytics. The first is called descriptive analytics. When we use descriptive analytics, we try to answer the question, what has happened? So when we do descriptive analytics, we usually generate the descriptive statistics of the dataset, such as the average, the standard deviation, the maximum value, and the minimum value. Second, predictive analytics. For these analytics methods, we use them to answer the question, what could happen? So we use advanced statistical models to forecast the future. For example, we can use a regression model or a machine learning model to forecast fraud or to forecast sales revenues. The last type, prescriptive analytics, are used to answer the question, what can we do or what should we do? These analytics methods provide solutions to problems. And in today's lecture, I will focus on the descriptive analytics. For more advanced analytics method, I refer you to take other related courses. Here are some very common tools when we perform data analytics. For basic data analytics tools, we usually use Microsoft Excel, SQL databases, R language, and Tableau. Tableau is for visualization. And I believe in your other courses, you must have learned how to use Tableau. For more advanced data analytics tools, we usually use SPSS, MATLAB, Python, Hadoop, Spark, and Hive. And in today's lecture, I will introduce Python, because Python is one of the most popular programming languages nowadays, and it is very close to natural language, so it's relatively easy to learn compared to other programming languages. Now, why do we want to combine data analytics with RPA? The answer is that RPA and data analytics complement each other because RPA can be used to automate some of the processes related to data collection and data cleaning, and data analytics will be used to analyze the data collected by RPA. The combination of RPA and data analytics is similar to that of combining RPA with AI, because each of these technologies complement each other and form an ecosystem of technologies that can achieve multifunctional service automation. And the combination of RPA, AI, and other technologies, including big data analytics, is called intelligent process automation. Now, let's download the software that we will use for our Python programming. You need to download the software called Anaconda via this website. Click Download, and then choose the correct version for your Windows system. And make sure that you are downloading the Anaconda software in your Windows system, because later we are going to combine this software with RPA.